So now we will look into creating the state diagram for JK flip-flop. Okay. Now, previous to this, we had seen this problem. Okay, wherein a circuit was given. Okay, so randomly any circuit can be given, and any question can be asked based on the circuit. You'll have to decide what is your output and what is your input, right? And once these values are there with you, okay, then the next step is to have the transition equation or characteristic equation, and substitute these values into those equations. Okay, and ultimately you will be able to generate the transition table. Initially you wouldn't get a proper transition table. You will have to decode them, okay, using your A and B. Okay, so now if you see here, there is only two states, 0 and 1, so you can use A and B. Okay, so we modify the table. Okay, we modify the table, and accordingly we try to develop the state diagram as well. Okay, so there's a connection between everything. Okay, without without this table you cannot get this diagram. Without this equation, okay, without this equation you cannot get this table. You cannot get this equation if you do not know the uh, characteristic equation. If you have to know characteristic equation, you have to know the excitation table and the truth table of T flip-flop, right? And in order to substitute, then you should always look into your circuit and know what is your input and output, right? So it's all interconnected. Okay, so this is one of the best examples that I have given here, which you can practice. Okay, right. So students, any doubts till this point that we have discussed so far? Because these concepts are very important. Okay, and if you have doubts, then yes, we can have a discussion. If not, then we can proceed to the next concept, to the next variation. You can unmute and respond.
No, sir.
So there's no doubts. So I can proceed.
Yes, sir.
Okay, fine. So moving on to the next concept, okay, wherein we'll be developing the state diagram for JK flip-flop. Can you all write the tabulation, okay? Or what I will do is I will show the tabulation, okay? And I want you to draw the state diagram for this, right? So the present state, we will take 3 bits, okay? 000 to 111 will be our normal combination, right? 0 0 0 1 2 3 4 5 6 7. This is going to be our normal combination, binary combination, and based on that, you can actually find out what is your qn plus 1, because you know your present output here. So when 0 0, okay, then you should be getting your output as 0. When it is 0 1, it's also 0. When it is 1 0, okay, then it is 1. When it is 1 1, then your output is toggled, right? So I have my output here qn as 0. So this is toggled and I get 1 here. Okay. So for this, you will have to know your truth table of JK flip-flop. Similarly here for 0 0, okay, there is going to be no change. Okay. The same thing is going to come here. Similarly here also 0 0, no change, same thing is going to come. The same thing was 0 here, so 0 is going to come here. And when it is 0 1, then it's going to be 0. When it is 1 0, it's going to be 1. When it is 1 1, it gets into toggle state. where the output here Qn, okay, is equal to 1, then my Qn plus 1 should be 0. So students, any doubts in this truth table? Any doubts, or you want me to repeat it?
Sir, repeat it, sir.
Okay. Now for our truth table, okay, the question is just going to be write the state diagram for JK flip-flop. So this is part of our answer. Okay. So what I'm doing here is I'm taking a 3-bit combination. Okay, because I need to know what is my output. So here my output, okay, is Qn. Okay, but initially I will be considering them as my present state. Okay, so what you can do a logical, you can put a logical line here. Okay, logical deviation, and we will take this as present state. We'll take this as input, and we will take this as next state. Okay, next state is ns, right? And this is ps, present state, input, next state. Now, in order to know next state, I should know what is my present state, isn't it? So my present state is here Qn, and my inputs are Jk. Now you should know that for your Jk flip-flop, whenever it is 0, okay, whenever it is 0, 0, then we will be using the same thing that is in the memory. Okay, so Qn is going to come. Okay, then when it is 0, 1, okay, just refer back to your notes. We should be getting 0. Okay, and then when it is 1, 0, okay, we should be getting the output as 1, and when it is 1, 1, we should be getting the output of Qn bar. So this thing you guys should know. Okay, so apply the same concept here. Okay, so 0, 0, Qn. So Qn is what? Qn is what here? 0, right? So this 0 will come and sit here. 0, 1. What is my output? 0. So this 0 will come here. Next 1, 0. 1, 0 is what? 1. 1, 1 is what? Qn. So I have to check for Qn. Qn is 0. 0 bar is what? 1. Any doubts here? Any doubts, students?
No, sir.
Okay. So use the same concept here. Okay. For the other half also. For the other half also. Okay. Now that you have the truth table, can you all generate the state diagram now for this? Think and generate the state diagram. So I will give you all a clue here. Okay. Since it's only one flip-flop, hence we'll be using 2 states. Okay. So we will take S0 when it is 0, and we will take S1 when it is 1. Okay. So we'll have 2 states, S0 and S1. And based on this, you try to solve it. All of you understood my question, right? Yes or no?
Sir, could you repeat the question again?
Yeah, the question is to create a state diagram for this. Now you have the table. Okay. So develop a state diagram for this. So have two states, S0 and S1. When it is 0, you name it as S0. When it is 1, you name it as S1. So ultimately, I want a state diagram. See, this is our state diagram, right? So I want a diagram for this problem, right? Have you all understood the question? Have you all understood the question?
Yes, sir.
Yes, yes. So try and develop the state diagram. Take two states, okay, S0 and S1. So have you all solved this problem? Anybody who has solved? Okay. So now this is going to be our solution. Okay. So here, what we have to do here is we have to group things together. Okay. So if you can see here, S0 I'll be taking when it is 0. Okay. Which means I'm doing a logical separation here. Okay. With 4 zeros and 4 ones. Okay, this side. And as usual, what I'll be doing here is when I have my 0 0, okay, and 1 0, I will have j as don't care, okay, because it is 0 and 1, and k as 0, okay, and my output is consequently it is 1, okay, and here also when it is 0 1 and 1 1, so k is going to be 1 and j is going to be don't care, right? So if you see our section here, okay, S0. So S0 is for this, okay, for the above section, and S1 is for the below section, okay. So here when I say 0 don't care, okay, so when I say 0 don't care, so which means j is equal to 0, okay, and my k is equal to in my S0, so which means I have to see in this section, okay, in this section. So here what I will do is when I say 0 don't care, okay, I will be considering this part, okay. So this 0 0 is taken as 0 and the 0 1 is taken as don't care, okay? And when I say S0, so S0 is 0, right? So this one is going to be my S0. It's going to be in the same state, S0. So that is why you can see that there is a arrow here, and I have two states, S0 and S1. Okay, right. And now we will go to the next state, okay, where j is equal to 1 1, okay, and k is what? K, what will it be when it is 0 and 1? Can you please unmute and respond? So what will it be? This combination, what is it going to be?
So
1 and don't care. No.
Yes, it's going to be 1 and don't care. And here, since it is 1 1, so which means it is going to S1 state, right? So this 1 don't care will come here, and this S1 will be here. So which means it is moving from one state to another state, right? Now, with respect to S1 now, in state S1. So here I have 0 0. Okay, here I have 0 0 and here I have 0 1. So which means I can write it as 0 and don't care, right? So this section is done. Okay, then similarly I can write it as 1 and don't care. 1 and don't care. Now here what I can do here is, this is one way of grouping, but here what is happening, uh, I don't have different or it is not in the same state. It's going 1 0 1 0. I cannot do in that fashion. Here I was able to do because both I have 0 0 and 1 1, right? So what I will do here is I will start grouping things. This one and this one I will group, and this 0 and this 0 I will group. So which means this kind of grouping I will not at all do. I will not do this grouping. I will group them based on my outputs. Okay. So what I will do now is I will regroup them. Okay. I will regroup them. Now, since we know that this 1 and 1 is here and 0 and 0 is here. So I will be comparing this one with this. Okay. So 0 1 becomes don't care, that is for J, and for K it is going to be 0. So that is what I'm bringing it here. And in that state, what is my output? 1. 1 means what? 1 means what? S1. So it's in the same state, S1. Now let us see the other case. Okay, in the other case, we are going to see, these two combinations. So here, since it's 0 1, okay, so J is going to be don't care, okay, and K is going to be 1. Okay, so that is what you are seeing, and it is going to 0. 0 means what? 0 means S not. So that is what you are seeing here. From S1 it is moving to S naught. So students, have you understood this concept here? Yes or no?
Yes, sir.
Okay. So the only thing here is, you should be able to analyze things in a proper manner. Okay. So you should be able to analyze it and then group them. Okay. So if you group them, then it becomes easy for you to get things done, right? So this kind of problems can be asked for your exam point of view, for your test. Okay. And now see, actually the question here is going to be only this. Okay. This is only my question. From here it's all answer. So what I did was I gave you a part of the answer. I gave you the truth table. Okay. And then I told you to develop the diagram. Right. So sometimes what I will do is I will just generally I will specify taking S0 and S1 for 0 and 1 respectively. So there you will have a clue that we need to have two states. Okay, two states means one state will be here, the other state will be here. Each state will have two combinations. For 0, what is the value? For 1, what is the value? Right. And what is going to be the output when it is 0? Okay, output for 0, what is it going to be? And for 1, what is it going to be? Right. So I will have to consider these values. What is my input, output, and two states, right? So if I have two states, then of course I will be having about 2 plus 2, 4 combinations, right? So in this way, you have to analyze your problems. Okay. So the next one we will be looking into is state reduction and assignment. Okay. Now here, what we are going to discuss is you're going to have a bigger state diagram. Okay. And due to some similarities, we can reduce them and we can actually convert it into a smaller state diagram. Okay. So this happens only when we have common data. Okay. See here I have 0 1, here also I have 0 1, and the next state also is AF, here also it's AF. So when I have multiple things like this repeating, I can just eliminate one of the state. Understanding, students? Are you all following? Are you all following what I'm trying to say?
Yes, sir.
Okay. So if there are repetitions here like this in this scenario, I will just eliminate one of the state. Okay. So this is called your state reduction and assignment. So we will see this probably in our upcoming class. Okay. So I want you all to just take a note of this table. Okay. Please take note of this tabulation. Okay. We will be having a discussion on this in our upcoming classes. The state reduction and the state assignment techniques. Okay, wherein it's very useful in order to get the states reduced, and indirectly we can reduce the graph, and once the graph is reduced, ultimately our circuit also can be minimized in a much better way. Yeah, is there any doubts that you want to discuss with the concepts that we discussed so far? Have you all understood the concepts explained? Yes, you can confirm.
Yes, sir.
Okay, fine then. So we will catch up with this problem, okay, in the upcoming class, because here we have to do reduction and then understand as to what is going to be the similarity, and accordingly we can proceed. Okay.